Good morning, dear students. Here is speaking Dr. Martinez from the surgical team. I'm together with Dr. Aguado and Dr. Arena, the teachers from Oral Surgery 4, to show you the practice about dental implants. Let's start by the normal instrument for that practice, which consists on the scalpel with the blade loaded. The blade is number 15. The Farabeuf, one of the Farabeuf retractors. The Adson tweezer. Periosteotome elevator. Lucas Bone curette. Periodontal probe. Needle holder, Mayo needle holder, some straight mosquitoes, and a scissor, surgical scissor. Well, we are going to make that practice of implants above that mandible, in that gap, in that edentulous gap, in the third quadrant, between the tooth 34, 35, and 37. And to remind you how is the box of the brand we are going to put this year on is the Naturactis, from the Naturactis model of implant from the ETK brand. It's a brand from South France in the Alps, close to the Mont Blanc. To the Mont Blanc and down those area, and I'll present you the full box of those ETK implants. There are two sides. The left part of the box, those are the drills for another implant which is called Natural. That is not the implant in which we are all going to focus today. We are going to insert one implant called Naturactis from the same brand, from the same ETK brand, that has different type of drills. At the beginning, like you knew from the Blackboard file we uploaded with the lecture of implants, both type of implants have the same type of drills, but lately it changes, and the Naturactis, which is the implant that we are going to install, follows with that helical drills, laser mark, each one of the marks each 2 millimeters, and that is the sequence to drill with those Naturactis implant. Now I'm going to show you how it comes, the implant, into a sterilized package. Of course, outside this ampoule, there is a blister. The outside part of the blister is non-sterilized, but when you open that blister, like it happens with the sutures, it comes the sterilized parts, and we remove the cap. And inside is the implant. I'm going to take it out to show you how is the implant. Well, that is an implant of 3.5 millimeters and 12 millimeters length. I put it back into the ampoule and put the cover on it. Well, now I'm going to show you the specific motor for implant. There will be a saline solution that will be driven with one interior motors through one line, through one pipeline, surgical pipeline, and it's mounted here and exits some amount of saline solution to drill with that irrigation, all the time with that irrigation. The motor consists on a reductor contraingle which is 20:1 reduction of speeds, and we work in implants not above 1,200 RPM. That is the top speed in which we want to work on. Above that speed, even if it will be with irrigation of saline solution, the osteocyte cells can dead about the friction of the drilling movement of the drilling. So we program, because there are several programs contained into that specific motor for implants, and we start by the program of 1,200 RPM. You will see how we change the different programs, and the following one will be in 800 RPM. That means that after starting with the first drills, which is the lance drill, we must go down with the RPM to decrease the rotation of our drills and to make less friction. We will get until, let's say, the drilling of putting the implant. The drilling for putting an implant is not more than 25 RPM, but you can see here that is written newtons by centimeters. That is an average of the torque in which we will use that torque to introduce finally our implant. And I must tell you that on those last minutes of installing an implant, we will not put the irrigation. It's not needed, and it's unuseful to use the irrigation in the last step of the sequence, which is the moment of installing the implant. Well, first of all, I'm going to start with the incision in that part of the implant, and it will be a crestal incision. The crestal incision makes on top of the dental crest, laying our scalpel right to the bone with a strong application of the forces of the blade, and some envelope cut around the neighbor tooth, which is in that case is the 37 tooth, and also in the case of the 34, an envelope cut around it. And well, it didn't bleed, so I cannot see anything. Well, I'm gonna use my periosteum elevator and just palpate what is the part of that incision. You can see that it was not completely well cutted. That sometimes happen because on the side of mesiodistal aspect of the neighbor tooth, you cannot perceive if we have cut it properly the soft tissue. So in many occasions you must repeat those parts of the incision around. And I'm gonna hold with my retractor. I'm gonna hold those tissues to get the crest exposed. The crest should be exposed. I'm gonna use that periosteum elevator to hold here the lingual tissue and to help myself. Well, anything. Well, let's go. I must release it, and I must mount the first drill, which is the lance drill. The lance drill is to mark the exact position of each implant, and of course that will be under 1,200 RPM and with cool saline solution irrigation. Let's hold again the tissue, and on the floor I have one pedal to press and to start the drill, the lance drill, as you can appreciate. I'm gonna put my implant close to the 37, because we need the other side to make the second implant. And I will start drilling, always in motion, the drill. And I must go up and down with all the drills, and only to mark that position. I don't have here any amount of whatever, and you can appreciate how I marked the position for the first implant. Well, let's mount the second one. And the second one will be what we call the pilot drill. Look at the box, first of all. On the box are represented, you can see different, what we call pilot drill. Don't pay attention to the words that are telling us pilot drill, because those are not pilot drill, those are lance drills. The pilot drills are the 2.2 drills. Those pilot drills, their indication is to make the final length of the implants and the direction of the implant. So that is a really important drill. We have different lengths, and we will choose the one of the length of our implant. That implant it's selected as a 3.5 of diameter and 12 millimeters of length, and I will choose that one, which is the 12 millimeters length. I will choose that one, 12 millimeters length, the 2.2 diameter, and I'm gonna retract again the soft tissue, and Dr. Arena will help me to retract the lingual side. And I start again in motion. I'm in 1,200 RPM, and you see here there is a one stop, because in this system of drills from the ETK, the first pilot drill is very accurate, and all those drills come with one stop, self-stop, and we will stop when we get to that side, because we have chosen the drill of 12 millimeters. So we start in motion the drill, and we go into, and we go up and down, up and down, up and down, until I touch the stop of the drill. Well, I blow. It's very casual, that recording, but you will understand our conditions. Yes. Following to that, I want to decrease the speed, because the first speed is to mark and to obtain the final length, but the following one should be at much less speed. The following drill is from 2.2, which are those group of drills, to 2.8. 2.8 we can choose or the short drill or the long drill. When we do choose the long one. We do choose the long one when we are drilling an implant in an interdental area, to avoid to hit with the crown of the neighbor tooth with the head of our contrangle. You can appreciate here that if I can choose the short one, perhaps I will hit against the crown of the neighbor. So I will choose here the long one, which is 2.2 to 2.8, and I will go until the mark of 12. It will start at the first laser mark in titanium, which is at 8 millimeters. If we follow, that is 8 millimeters. If we follow to the black one, we will obtain 10 millimeters. And if we go further, we will get to the 12 millimeters. Okay, that is the site for drilling. When it's in motion, that drill, you can better see the laser mark onto it. And, well, another thing is that the bottom of that drill, it cuts that much. And you must take it in account in cases like that one, when the inferior alveolar nerve is running across the bottom of that side. Everything has been to be programmed before in the treatment plan with a CT scan, with a CBCT scan, to know exactly where is located the inferior alveolar nerve and to don't damage with the bottom of our drill that inferior alveolar nerve. So 8, 10 and 12, I must get to that site when I drill there. And well, let's go drilling, always in motion, but now in 800 RPM. Well, now to check the depth in that box, we have some gauge. That gauge is also calibrated from, let's say, from 8 to 10, no, that's 6, I think. 6, 8, 10, and 12. Let's check if we are on the right side. 6, 8, 10, 12. This is the fourth mark. 1, 2, 3, 4. Perfect. We are done. So when we have checked the depth with that gauge, we go to the next drilling. And now I want to tell you one thing. That depends on the quality of bone. You can appreciate here some guidelines according to the type of bone. My drilling, because we didn't have previously show you any type of CT scan to know in advance what type of bone are we talking about, I tell you that my drilling is a type 3, type 2. It's my perception. I'm well skilled, and without a CT scan, I can tell you that the density of that bone is 2, D2, D3. So if you look at those lines, they are telling that for an implant of 3.5, we must go in bone type D3 or D2. We must go from the drill 1, which is the lance 1, to the drill 2, which is the pilot 2.2 drill, to the drill 3, which is the one we have already passed of 2.2 to 2.4, to the last one, which is the drill number 4, which is that one from 2.8 to 2.3. That considering that the type of bone is 2.2, 2.3. If the type of bone will be less density, I will not pass that drill of number 4 of 2.8, 3.3, because I want that the bone trabecle become more stretched when I introduce the implant coming from 2.8, which is the last diameter pass, till the diameter of 3.5, which is the final diameter of the implant. In cases of opposite situation with density bone of D1, which is in the symphysis area of a high bone density, I will need to pass, of course, that last drill of 2.8 till 3.3, and on top of that, I will pass those those drills, which are called bone taper. Bone taper for the implants of 3.5 are coded in color. If it will be a larger diameter, the code color will be in blue, more large will be in color green, and the greater diameter will be in color purple. Well, for our implants, the bone taper is that one that is exactly 3.5 of diameter, because in the bone type density D1, which is the highly density in bone mandible, is necessary to match the final diameter of the drilling, which is that one, with the final diameter of the implant, which is 3.5. So that specific bone taper can be passed at a really low speed, at 25 RPM with a contrangle, or manually, and manually is with, no, because we need the transformer. Let's say, I don't have it. No, I cannot see. Well, there should be here one mounted handle to put here. No, those are the screws. Those are the screws. Sorry, the manually handle to insert the implant. I cannot have here any one of those. I'm sorry. There should be here one of those handle, and they will be mounted right here to permit to clockwise manage the drilling to match exactly the socket, the artificial socket, to the diameter, the final diameter of the implant. No, I don't think there are. No, there is not. Well, perhaps are in another box, I'm sorry. But it's easy, it's only, that is the ratchet that you can understand, and it's easy, it's like those handle, one piece which is introduced here and permits you to adapt that part to the bone ratchet. Well, that is not the question of today's implant, because the bone quality here is not like in the case of the symphysis. So we don't need to pass those bone taper. And well, I'm going to pass, I'm going to replace that drill, which is the 2.2, 2.8. And as I told you, we are talking about a bone density D2, D3, and that's the last drill that is with which reach to 3.3 diameter, and well, I'm gonna transform again the speed of drilling. I would like to drill in well, let's say in 15. No, I want to decrease to show you what we call the biological drilling. We call biological drilling one specific drilling that is done on the last drilling sequence without saline solution. Is not needed saline solution, and that is able to drill in a very slow speed with no damages to the osteocyte, and that retrieves a lot of grafting material just in case it was needed for grafting in some areas. Here it is not needed, but just in case it will be needed. And look how it turns very slow, the drill, because we are drilling at 50 RPM, and again up and down, and I appreciate that it's a quite tough bone quality, so perhaps it should be more tough, the drilling. Let me go down. I'm almost there. Well, it was, oh, I cannot stand it. Well, I think I'm there. Let me check. Let me check again how is the depth of that drilling. And 1, 2, 3, the fourth side. 1, 2, 3, the fourth side. Yes, I'm there. So now is the moment of introducing the implant, and for that purpose we are going to choose one of those implant holder. There are manual implant holder that can be introduced with the ratchet, using the ratchet, and with the contrangle, which are those two implant holder. That is the one, the long, and that is the short one. Those are similar, and I'm gonna use the long one. Here comes another important thing according to this type of implant. Well, you can appreciate the laser mark into that part of the implant holder. Well, the first narrow one, it only works for holding the implant. That means that for holding the implant, that laser mark should be into the connection, the internal connection. I haven't told you that the connection of those implants is internal, not external. It's an internal connection, and it's an hexagon, that connection. And it will be introduced up to the narrow mark. And the other laser mark means about the depth of introducing that implant according to the crystal surface. Those implants are prepared to be in a crystal position, but much better they work in 1 millimeter subcrystal position. That specific design, macro design of implant with that really aggressive thread in the bottom of the implant of the and that really narrow thread in the neck of the implant. The narrow thread is better for the cortical part of bone. Well, and now to introduce our implant, we select the program of an implant in the implant motor, and the speed of introducing our implant will be not more than 20 RPM, and always clockwise, of course, and with no saline solution in irrigation. We have choose an average of 40 NCM to expect or for expecting that when we introduce the implant, it will stop at certain moment, and we will follow introducing all the implants with the ratchet manually to show you that part. And well, now we are on the most delicate moment, which is to hold the implant without touching it. The implant cannot be touched with bare hands, only can be touched with the driver, with the implant holder. We check everything is all right, that is clockwise sense of the motor, because those motors are designed also to make an anti-clockwise to retrieve an implant which is not in an appropriate way. And now we choose every the proper direction, clockwise, the appropriate average of torque. We hold the implant and we put the implant on top of our perforation, and I press the pedal, and he turns very slowly, very slowly, very, very slowly. Well, as you can see, I was able to introduce the implant almost to that side of the preparation. Now it's in a crystal position. I would like, if it was not prepared in that way, to introduce the last part of the implant manually, only to permit you to see what is going on with that ratchet. The ratchet has two parts. One part is with some letters on top, and that is the position to introduce an implant clockwise. And if we put on the other side, we will move it anti-clockwise and we will remove it. But we will set that manual implant holder, which is equal to the motor handle implant holder equally, and we introduce into the implant, and clockwise I turn slowly the ratchet, not that much. Look at how I have introduced the implant. Now the implant is introduced to the first line, to the first laser line. That means that I have introduced the implant till 1 millimeter in a subcrystal position. I can do it further and I can introduce it more. Can you hear the noise of the ratchet? and I think it's enough. I think it's an appropriate site for leaving the implants. How to close that implant? Well, here, can you see it into the cover of the implant? There is a cover screw. Well, we can use the cover screw to close the entrance of the implant. We unscrew the cover screw and we put it manually. We put it manually and we allow it for osseointegration. That is the right position for that type of implant. Well, everything is done. We must check before suturing. We must check the right position of that implant to show if it's not damaging any inferior alveolar structure, of course, and to show us how it's in relationship with the neighbor tooth, And we make some suture that could be simple interrupted suture, here around, another here interrupted suture, and another one. And we are done with the implants. Well, hoping you have understood everything about the box, and those are the things we are going to show you about the implant practice. And we are done.